All right then, everybody. Let's have a look today. Today we're going to be looking at the sine and cosine function. It's important for us to be able to determine the coordinates of the points on a circle centered around the origin. Right, here we got the unit circle. Coordinates of a point on a circle centered around the origin. Given the angle A and theta in standard position on a circle with radius centered at the origin, there's a point P where the terminal ray intersects the circle. We can see that here in the diagram. We call it the unit circle if R is equal to 1. But here, R isn't equal to 1, it's equal to R. So the coordinates of the point are going to be R cos theta and R sin theta. Right then, we're going to have a go at example number 1. The figure shows a circle of radius 4 along with an equilateral triangle PQ0. Which of the following gives the coordinates of point Q? Right then, how are you going to figure this one out? It looks like a really hard thing to do, doesn't it? Take yourselves a couple of minutes, sit down, have a nice cup of tea, and see if you can solve the problem. Right then, the key to this question lies here in this equilateral triangle business. So an equilateral triangle, if I draw one out like this, make it a little bit more equilateral. We need to know what the angle is in an equilateral triangle. What is the size of an angle in an equilateral triangle? 60 degrees. So if this is 60 degrees, what do we say in radians this is? Here, it's going to be pi over 3, isn't it? Now, half of that is how much? Pi over 6, you say? So that means this little bit of angle here has to be pi over 6. And this bit of angle here has to be pi over 3. And then this one has to be pi over 3. So the whole angle, I'll draw that one in red like, is going to be 2 pi over 3. So the coordinates of that point, that terminal ray there, is given by 2 pi over 3. We can also see here that the radius is 4. So the coordinates of the point have to be 4 times the cosine of pi over 3 and 4 times the sine of pi over 3. So C has to be the right answer. Abdullah? Which will be negative. Let me just pull that apart. No? Ooh. Yeah, the cosine is going to be negative because it's the cosine of 2 pi over 3 that produces the negative here. So if you were to evaluate that, it's the cosine of 2 pi over 3, which is going to give you minus an half. So you'll end up with minus 2 as your coordinate, won't you? No, because it's the cosine of 2 pi over 3, which will produce the negative. You're actually right in knowing that, wait a minute, the cosine value is going to be negative, but it's the cosine of this obtuse angle which is producing the negative and introducing the negative value. You see? Yeah, it's asking for this point up here. So we know at this point here that the cosine value is going to be negative and the sine value is going to be negative. But, sorry, the sine value is going to be positive. Yeah, you're right there. So it's the cosine of 2 pi over 3, which is equal to minus the cosine of pi over 3, which is equal to minus an half. So it's actually the cosine of 2 pi over 3 that introduces the negative symbol in it.
So the cosine of 2 pi over 3 is the same as negative.
So the cosine of 2 pi over 3 is the same as minus the cosine of pi over 3 due to the symmetrical nature of angles in the unit circle.
So if I were to put this as a minus, what would
No, minus an half. So cosine of 2 pi over 3 is minus a half. Oh, if you want to always miss valuable information, you're welcome to, mate. But I, myself personally, wouldn't be recommending it to you. Right, I'm taking my Peaky hat off for you now. Okay, we're moving on to example number 2 in today's episode of APPC Calculus, brought to you by Peaky Blinders. So, example number 2. The figure shows a circle of radius r, along with the line y equals minus x. The circle and the line y equals minus x intersect each other at points r, o, and p. If the coordinates of p are given here as 6 root 2 and minus 6 root 2, what is the value of r? Okay. I'll give you 1 minute to have a little go at this one. Okay, so we're going to little look at this one out. Now, it's a bit of difficult problem solving on that one, but here we're given that y equals minus x. So, can anyone tell me what the tangent of theta is going to be? Not quite, my little friend. What's it going to actually be? -1. What does this imply that the value of theta is? At point P. What's the value of theta at point P? What's the value of theta at point P? Ooh, 7 pi over 4 minus pi over 4 is equivalent. So what he's doing here, he's thinking about the exact value table, and that the tangent of pi over 4 is equal to 1. But because we're down here in this quadrant down there, so that's going wrong. We've got minus pi over 4 here. And then he's saying that this is 8 pi over 4 minus 1 pi over 4, which gives him 7 pi over 4, doesn't it? So, now we know the theta is 7 pi over 4. What is the cosine of 7 pi over 4? Cosine of 7 pi over 4 is going to be the cosine of pi over 4. Root 2 over 2. So r times root 2 over 2 equals 6 root 2. What's the value of r? 12, isn't it?
So I did it. I used it like no, I don't know how to. I don't understand how to call 7 pi over 4
Did you use the Pythagorean identity, you said?
No, the theorem, the A squared. Because if you square the limits together, if you have 4 to 1,
Let's see if it works.
no, you have to go up to the.
So we can say that the cosine theta squared plus the sine of squared of theta is equal to 1 squared.
No, I just did 6 times 2 to the whole square plus minus 6 to the whole square.
This gives us this r sine squared theta equals r, which means that 6 root 2 plus negative 6 root 2 is equal to r.
Yeah,
Not quite.
no, the next
Squared.
yeah. And that one is also squared. Because then we get 36 times 2 is 72 plus 36 times 22 is 144 squared.
So can do this with for real. So the other one is too much pi. This one.
Oh, I like the first one better.
So what does that say? Cosine something before? Is that pi? Or the top, at the top?
Where?
Cosine, is that pi, sir?
Yeah,
Or is that 7 pi?
7 pi.
How does cosine 7 pi? So can you explain that line again if you don't mind?
Yeah. Okay, so in this solution, we get the tangent value given here. So where the slope is -1, which means the tangent of theta is -1. If the tangent of theta is -1, and it's in this quadrant down here, then theta has to be 7 pi over 4. So the cosine of 7 pi over 4 is equal to root 2 over 2. Sorry, is equal to is equal to root 2 over 2. So r times root over 2 has to be equal to this coordinate here. Because we're using the fact, in a lot of these questions, we're using the fact that the coordinates of any point is r cosine theta, r sine theta. So if we find out what theta is, we can find out what the cosine of theta is, and then r times that value has to be equal to the x coordinate. And that's what the technique uses. Like this. So here is pi over 4. Here is 7 pi over 4. They have the same cosine value. This is the cosine of both of them. This is the cosine of 7 pi over 4. This length here. The x coordinate is the same. The x-coordinate of pi over 4, of cosine of pi over, well, cosine of pi over 4 is the cosine of the x-coordinate. And the x-coordinate at both this point here and this point P is the same. They have the same x-coordinate. We're finding the P point, but the x-coordinate of the P point is the same as the x-coordinate of the, call it Q, of the Q point. They have the same x-coordinate, which is what this equality symbol says here. Okay, let's move on to the next one. Oh, either, fine. They're both true. All right, so consider the unit circle above and find the value of each one of these points. I'll give you 4 minutes for this one. It's quite easy. Right then, have a little go with that one. All right. So, from the unit circle, the cosine is the x value, sine is the y value. So first off, we're here. So the cosine here is 1, the sine here is 0. Next up, we're up here. The cosine value here is 0, and the sine value is 1. Now we're over here, aren't we? The cosine of pi, sine of pi. So this is going to be -1 and 0. Lastly, we're down here. So it's 0 and -1. Okay. Oof. What's it? Okay. What it's introducing here is the Pythagorean identity. Let me just explain this. If we take a unit circle like this one, then the coordinates of this point is cosine theta, sine theta. This angle here is theta. This length here is x, is cosine theta. This length here, y, is sine theta. So y equals sine theta. X equals cosine theta. Because it's a unit circle, this equals 1. So from Pythagoras, theorem, we can say that r squared equals a squared plus b squared. Now that's going to be 1 equals the cosine squared of theta. Well, let me do it the other way around. Sine squared theta plus cosine squared theta. For some of you, the notation I'm using here might be the first time you've seen it. So for instance, if we want this, the cosine of theta, we want to square everything. The notation is that we write it like this, cosine squared theta. Because if we want this, then we write this. So that the two don't get confused when you're not using the brackets, we write them like this. So up here we get what we call the Pythagorean identity, which is a very important and useful trigonometric identity. You saw a minute ago, Perva, when she solved that last problem, she was basically using the Pythagorean identity. She was just using Pythagoras and just directly applying it in there. But when I pulled it off, I started straight into the Pythagorean identity, and we had the same solution. Because it is Pythagoras' theorem in a unit circle. So, this is our formula. let's have a look at how we can use it in this problem-solving situation. We got one more problem here. Okay, so in the xy plane, the terminal ray of angle theta in standard position intersects a circle of radius 10 at the point x comma 6. What is the value of x? So my first question for you guys is, what is the sine of theta? Discuss with the people next to you.
So what's the terminal ray again? Is it the hypotenuse? The terminal ray.
Yes. Why?
Okay. We know this value on the other side.
Okay, what is the value of sine theta? No. What is sine theta? No. No. Okay, what you're missing here is this circle is not a unit circle. Let's whiz back to the beginning. When we have a dilation of the circle by r, then the coordinates are r cosine theta, r sine theta. When we have a dilation by r, the coordinates are r sine theta, r cos theta, r sine theta. So in this question, what is the sine of theta? The coordinates are going to be 6 over 10 or 3 over 5. Double check, the sine values always have to be between -1 and 1. So 6 is way too big. You're forgetting something. Have that double check in your head all the time. So the coordinate 6 is, so the coordinates are r cosine theta, r sine theta. This is the coordinates of the points on the circle. So r sine theta is equal to 6, which implies that sine theta is 3 over 5. All right, that's the first part. Next up, we'll use the Pythagorean identity. And this tells us that 1 is equal to sine squared theta plus cosine squared theta. This is the identity, always. This is the identity. So into that, we can say that 1 is equal to 3 over 5 squared plus cosine squared theta. No, not. We're only looking at the sine value and the cosine value. So, rearranging this, we get the cosine squared theta is equal to 25 minus 9 all over 25. I probably did that too quickly for some of you. Let me do it slower. Let's rearrange it. We get cosine squared theta equals 1 minus 3 over 5 squared. Cosine squared theta equals, well, 1 could be 25 over 25. And then squaring the top and the bottom, we get 9 over 25. So we get 16 over 25. This means that the cosine of theta is equal to plus minus the square root of 16 over 25, which is equal to plus minus 4 over 5. I'm just rereading the question. to see if there's anything in the question that implies which quadrant we're in. So in this one, we know which quadrant could we be in. Medea? We could be in the first or second quadrant because we know for certain that the y value is positive. We don't know. So in the second quadrant, a negative cosine value would be reasonable. And in the first quadrant, a positive cosine value would be reasonable. So lastly, we're asked to find the coordinates of, coordinate x. Now x is equal to r cosine theta, which is equal to 10 times plus minus 4 over 5, which is going to be plus or minus 8. Is it a good one?
No.
Oh, okay then. But hit you admit it anyway. That's what I used.
Yes, but you took the whole thing.
Only because I wanted to over-explain it. There's a whole bunch of shortcuts you can do in this one. I just don't do them because I'm showing the full solution so that everybody gets it. Once you get experience, you then start shortening the pathway.
You could also just put 10 as a radius instead of 1, right?
Yeah. So what you can do... Sorry, let me try it like this. What you can do is basically just see it like... Okay, so what you can do is you can just see it as a right-angled triangle where you've got 8 here, and you had 6 there. No, sorry, 8 there. 10 here, 6 here, and this is how you get to the 8. All right, last question, exam-style question. Take 2 minutes for this one. All right. So, first off, we've got an angle of pi over 6 radians. Let's have a look at that. We draw a unit circle. Pi over 6 is going to be here. This here is the angle this is the angle 5 pi over 6, which means that this angle here is minus pi over 6. So we need to turn to the exact value table. And we need the values for pi over 6 to help us solve this one. So sine, cosine, tangent. This is 0, 1, 0. This one is 1 over 2, and this is root 3 over 2. This one's 1 over root 3. So this part of the exact value table is what we need. So next up, we've got a radius of 4. So the coordinates of the circle are going to be r cosine theta, r sine theta. So that's going to give us 4 times the cosine of theta. It's going to be, the cosine of 5 pi over 6, comma, 4 times the sine of 5 pi over 6. Now we are in the second quadrant, so the cosine value will be negative. So it will be negative root 3 over 2. So this should give us 4 times negative root 3 over 2. And 4 times a half. So we should get minus 2 root 3 and 2. I think this one matches here. Okay, that is it for the lecture for today. We have a classwork activity to do now in class.